I will start recording again from now. So yes. Okay. So again, we have artificial element for some cases, or mainly most of the cases, that we have to subdivide the structure to smaller elements, like triangular elements or rectangular or generally quadrilateral elements. As this one to the right, to the left, sorry, structure A is an example of retaining wall or dam. So we subdivide it to smaller triangular elements. And the example to the left is an example of deep beam. We subdivide it to rectangular element. Okay, and this means that generally or superficially, we the structure or the finite element modeling is reduced by sewing the actual structure apart and then pinning it back at the nodes. So this is the main idea about the method, like subdivide to smaller elements and then connect at nodes, because the nodes has same displacement. Okay, so now we jump to the next slide. This is the main part you need to know before using the software, that you are responsible for the result or the design or the outcome of the software, because any software can be taught to anybody, but the outcome or the judgment of the results can be done only by engineer or structural engineer. Okay, so you have a responsibility that finite element computer programs have become widely available and a lot of software available in the market and easier to use and can display results with attractive graphics. So if you put any input to the software, you will get some results. And it sometimes looks good, but actually it is not logic or incorrect. So it is hard to disbelieve the finite element result because the effort needed to get them. And also because you already done a lot of effort and a lot of research to do the model. So it will be hard to disbelieve or don't trust the result you got from the software. However, in some software and some smooth and colorful stress controls can be produced by any model, good or bad. This means that any input you will put to the software, you will get controls. But if the model is good, the result will be accurate and trustful. Otherwise, if the model is bad or there is mistakes in the model, you will get same colorful shapes, but not accurate or not correct. So this is your responsibility as engineer to has the skills and the background to use the software and get good models. Otherwise, there will be design errors and sometimes structure collapse like bridges, or as you mentioned, as you see before, the bridge collapse in FIU bridge. Okay, so the responsibility for the result produced is taken by the engineer who use the software and not the software vendor. Because sometimes also there is some error from the software itself, or the software has some weak points. So even that, the result, if there is error in the result, it is your problem or your responsibility. So you need to make sure that the result you get from the software is correct and acceptable. Otherwise, you don't have to use the software, or you have to modify the result or use another software. So the responsibility will also come on your side, even if the software itself has problems. Okay. Second step, the second point is the finite element model requires that the physical action of the problem to be understood well enough to choose a suitable kind of elements. Okay, so you need to know how the structure perform or how the loads apply to the structure to select the appropriate type of elements. Because as you see before earlier, that we have many type of elements and some of them are very close to each other. So we need to understand and have well understanding of the structure and how the laws apply to it. Okay, when the computer has done the calculation, we must always check the result to see if they are reasonable and acceptable. Modeling and errors will be further discussed in the following lecture. This is just a brief introduction of the responsibility on your side when you use the software, not just put input onto the software and get the result and that's it. You have also to have the engineering sense to judge the results and to know if it is correct or acceptable or lie within the range, something like this. Okay, and this is an example of finite element model. As you can see, this is a curved beam or a curved structure supported by these rollers and hinge, has a size H and L, and we have a load applied here B on the side BCD. So you need to know that finite element calculates nodal displacement first. So what the finite element will do, as we mentioned before, you will do the steps of analysis, like define the analysis method, define the elements, define the material properties, define the loading, define the boundary condition at A size, and then perform the analysis or run the model if it is modeled on on the software, and then post process the result. But we need to know that the software or the finite element method, the first outcome or the first result is the nodal displacement. So you can find the nodal displacement at D and C, for example, like this one, and here also at B. And then using this displacement, you can calculate the strains and finally the stress. So this is the procedure of how the method works. Find the displacements first, because what we can do only using the finite element method is with nodes. So you can work with nodes and get the displacement or the nodal displacement. Then after this, you will learn how to convert the nodal displacement to strains, and from the strains and using the material properties, you can find the stresses. Okay, so the first step you have to do on software, you have to examine the computed displacement first, and then check the stresses and strains. Okay. This also another recent example at Arab, is a company in Australia or an international company, has a lot of branches in Australia. So the problem was cracking and excessive deflection in new three stories concrete framed structure. So they noticed cracking and excessive deflection in some parts of the new building. So when they check or review the design, they found that the design was based on 3D computer analysis package, which may be Strand 7 or Space Gas or MicroStrand or whatever the software, but any software or any finite modeling software is based on finite element analysis method. So it doesn't matter what the software is, but it causes a problem. So when they check the problem, they found that the torsion in concrete was not considered in the model. The application of the loading, the forces were not compatible with the behavior of the actual structure. So the actual structure has load different from the load in the design process. This also causes a problem. Okay, also the construction sequences. So the construction process must be taken in consideration because sometimes your design is built or based on a construction process which is different from real life. So some structure or some model will be affected if the construction process doesn't doesn't have been considered or haven't been considered. Sorry. Okay. Also, another problem they found that the member properties or the material properties, the effect of cracking and the creep must be considered. Okay, because as you know, the concrete as a material has some creep and shrinkage properties. Sometimes the engineer doesn't take in consideration when designing concrete, but some models need to take in consideration the creep and shrinkage properties of concrete. Okay, so as you can see, this is an example of how the design was incorrect because of some like lacking of consideration of some things like the torsion, the application of loading, the sequence of construction, the member properties, which because maybe like sometimes the structure may collapse. For this one, it has some cracking and excessive deflection, which will need some repair or some enhancement. But for some other cases, will be worse and it may collapse. So please keep in mind these responsibilities and these notes to when you go for structural engineering career, you need to consider all this stuff in your modeling. Okay, and here is the procedure of finite element analysis. As you can see, this is like a flow chart of the finite element process. The first thing here to the left is if we have a problem must be solved. So then we have two options. Is finite element analysis required? So we have yes or no. If no, this means that the model is easy or not complicated, so we can do it analytically or experimentally. So if we don't need a finite element model, so we go to the analytical solution, still stop. So this is not our case, or this will be for the simple cases only. Another scenario is we have finite element analysis required. So we have yes. So what we need to do is anticipate the physical behavior plan and how and anticipate the physical behavior to understand what is the behavior of the structure or the problem, plan how the result will be checked to see if they are reasonable. So we need to know which output of the software we will check, like deflection, stress, strain, and so on. So the first step is to plan an initial finite element model and pre-process to prepare the model. As we mentioned before, define the element, define the analysis, define the boundary conditions, define the loads, and then solve the equation of finite element model, and then post-process and display the finite element model results using software or manually. Then are the results. Then the next step after post-process, we will check the result. Are the results reasonable? Any error, even small? Does model revision do little to alter computed results? So also because you have already done like software analysis or modeling using software, you have to check some of the results manually, like simple calculation to check how far is the software result from the manual calculation. If they are okay, if the results are reasonable and everything is okay, so the modeling is finished and stop. If not, so this means that the model need to be revised. So you have to plan a revised model again using insight provided from the current model. Like you have already checked the model and see some errors or some modification needed. So you will like redo the analysis or remake the model again and then again same process, pre-process and prepare the model again, solve the equation and post-process. So the three steps in the dotted rectangular will be repeated until we find a reasonable result. So because of this process is or the finite element analysis cannot be exact or cannot be accurate from first time because sometimes you find modifications or refinement of the model. So this step or these three steps in the dotted rectangular may be repeated 3 or 4 times until we finally get the accurate or the acceptable result. Okay, so we will keep this process, post process the result, check if the result reasonable. If not, revise again and pre-process until we find the final result. Okay, so this is a mind map or a flow chart of the procedure for finite element analysis and what we can do to get a good result from the software. Okay, the final slide is what is a finite element analysis? It's just a summary of what we have said and what you think about the finite element software or finite element analysis. Is the finite element analysis a graphics tool to make a pretty images or a perfect example of garbage in and garbage out, or a powerful stress tool or a stress analysis tool, or a method of for solving boundary values problem, or all of the above? What do you think? The first two are related to what we have said about the responsibility of you as engineer, because as we mentioned before, any input you will put in the software, you will get results. So this is the meaning of garbage in, garbage out. If the input is garbage, so the output will be garbage. So that's why you need to be careful when you input the data to the software. Also, the software analysis or the finite element model using software like Strand 7 will give you pretty pictures because the contour, like the colorful contour, any software or any model will give you contour, but sometimes the contour are useless or garbage. So doesn't mean that the photo are pretty. It is correct. So you need to make sure the results are correct. And the main rule or the main use of the finite element analysis, as it is a powerful stress analysis tool. As we mentioned, we have type of analysis: linear, non-linear, static, and dynamic. And also, it is a method for solving boundary values problems. And because you have any structure has boundary conditions and need to model or define the boundary condition to get the results. So the finite element analysis is all of the above. Okay, this is just a summary of what we have said during this lecture, and that's it for today. Do you have any questions or anything I need to repeat or need to focus on again? Any question? Any comment like my voice was not clear, my I was very quick, or anything to improve next time? If you have any comment or anything, you can send me a private message on my email address or even here in the chat. Okay. Okay, Gilbert, I will do that. So you mean lower or slower? Slower? Okay. So my speaking was too fast for you today? Okay. So I will try to be a little bit slower next time. I'm sorry for that today, but next